Hello everyone, my name is Shubham. Back to our cybersecurity learning roadmap series. What we are doing in this series is our first module, which is pre-security. So if I go inside the pre-security, you know that we have done a lot of modules in this series. So let's take a quick recap because what I have done in my previous video is a room which is also from TryHackMe. In that room, I hacked the gallery, a simple image gallery system, which is a content management system. In that, what we have done was uh, exploiting some sweet bits that will eventually make us root, elevated our privileges, and we are managed to pawn that machine. So today we are back to our roadmap, which is cybersecurity learning roadmap. And the recap is we have done the introduction to cybersecurity. You know that computer fundamentals and operating system, that will be our next module after our current one. So network fundamentals is already done. How the web works is already done. So where we are in our computer fundamentals module, and in this module we are in our last chapter, which is cloud computing fundamentals, and it is a very important part of the cybersecurity learning series. So we are gonna go inside that room, and you can see this is the premium room. If you want to follow along with me, you have to have the subscription, but if you don't want the subscription, just pull up your notes and start taking screenshot of the topics that you are going to see inside your screen. So before any further ado, let's start with this room. Let me click on the join room button so that we are in this room, and the first task is introduction. Imagine you have a fantastic idea for an app that helps students practice cybersecurity, and you host it on your own computer in your country. But what you can do when users from other parts of the world try to access it and experience lags? What if many students connect at the same time, or your computer is turned off? These limits make it hard for the app to grow. That's when cloud computing comes to play and solves these problems. The cloud is built on top of technologies you always learned, like virtualization and containers. So we have covered these two topics in my previous video. So if you're interested in learning virtualization, and inside the virtualization we have containers, you should watch that video first. That is virtualization basics, and then you can come to this video. These enable running many applications efficiently on shared infrastructure and quickly creating or changing environments when needed. So this is a very nice picture of cloud computing. In this room, we will explore the basics of cloud computing and how this impacts the way modern applications are built, deployed, and used every day. Learning objectives. So, what we are going to learn in this module is what is cloud computing, services models of cloud like IaaS, PaaS, and SaaS infrastructures, cloud types, which is private, public, hybrid, benefits of cloud computing, how big companies are using the cloud, what are the prerequisites, which is virtualization basics. And I already told you that this is my previous video. If you are following this series, which is cybersecurity learning roadmap, you know that our previous video in that series was virtualization basics. So you should see that video, or you should watch that video. Now let's go to our task 2, which is cloud computing overview. Cloud computing is the perfect solution for the challenges in the applications you have designed, such as moving your files from a single laptop to online storage that you can access anywhere. Instead of running your app on one computer in one country, the cloud lets you use computing resources over the internet. This makes your application easier to access, more reliable, and ready to grow as more students start using it. How servers evolved to cloud. Before we start diving into cloud details, it's helpful to understand that cloud computing did not appear suddenly. It is the result of many years of changes in how servers were used and managed. At each step, businesses looked for ways to reduce costs, use resources more efficiently, and make their applications easier to run and scale. The timeline below shows the evolution from physical servers to the cloud we use today. So, evolution to the cloud. This is a very nice graphic. Let me zoom out a little bit so that you can take a good screenshot and dump that into your notes. So let's understand the evolution. So what we have previously was physical servers. We are talking about 1960s to early 2000s. These are the physical machines that are racked up inside a separate room where the servers all they were the where all the servers are running, and what it says is physical servers in company buildings. One server is equal to one job, expensive and slow to scale. So imagine if you have one server and that server is only completing one task, how much tedious it will be to manage these massive amount of servers. So what is the solution of for that is virtualization, which comes in 1999 to 2006. And what are the properties or advantages of that is multiple virtual servers on one machine, better hardware utilization, faster provisioning. And after that, automation and remote management 2003 to 2006, servers managed over the internet. Early automation infrastructure become faster and flexible. And after that, what we have is cloud computing, which is AWS launch 2006. Maybe in 2006, Amazon Web Services comes into play, I think. Rent, virtual computers, and storage on demand. No hardware ownership, plastic scaling in minutes. After that, modern cloud era, which is 2012 to today. So, AWS, Azure, Google Cloud containers focus on apps, not servers, global scale platforms. So, this is the evolution that we just see now. Cloud benefits and characteristics. After seeing how applications evolved from physical servers to the cloud, it's becoming clear why cloud computing is so widely used today. The cloud was designed to address common problems, including limited capacity, high costs, and slow growth. The following benefits and characteristics explain how cloud computing makes applications easier to run, scale, and manage. So, what are those? Benefits is scalability, easily scale up or down as your applications needs change. On demand self-service, create or remove servers and storage instantly without waiting for hardware. Pay only for what you use. You are charged based on usage, up- not upfront costs. That should be no upfront costs. Security. Cloud providers protect the infrastructure with strong security measures. High availability. Applications keep running even if part of the system fails. Global access. Your application can be accessed by users anywhere in the world. In simple terms, the cloud enables IT resources to be flexible, cost effective, and easier to manage. Types of cloud. The flexibility provided by cloud computing allows application to be run in different ways, depending on your needs and level of control. Because of this, cloud providers offer multiple models for deploying and using applications, each suited to different scenarios. Let's start with the deployment types you can choose for a cloud infrastructure. So, the first is public cloud, used by startups, websites, and global apps because of its affordable, easy to scale, and requires no infrastructure management. Public cloud services are preferable for nearly every use case. Now, the second one is private cloud, used by banks, healthcare, and government organizations because it offers greater control, customization, and compliance for sensitive data. The third is hybrid cloud, used by companies like e commerce platforms that need to keep sensitive data private while still scaling publicly during high demand. Just like there are different ways to deploy a cloud environment, there are also different ways to use cloud services. Depending on experience and needs, you can choose the level of responsibility that fits your application. Let's look at the main cloud service models. So, what are the main cloud service models we have is infrastructure as a service, platform as a service, software as a service. Now, the first one is IaaS. You rent basic computing resources such as virtual servers, storage, and networking. You are responsible for managing the operating system and your application, while the provider manages the physical hardware. Now, inside the PaaS, the cloud provider manages the infrastructure and the operating system. You focus on building, deploying, and running your application without worrying about servers. The third one is software as a service, that is SaaS. You use a complete application over the internet. The provider manages everything and you access the software through a browser or app, for example, Gmail or Zoom. Think of cloud service models like different ways of renting places to live. Now, this is also a very good example to understanding these three services that we have is IaaS, PaaS, and SaaS. So, in SaaS, renting an empty apartment. So you can get an apartment, but there is no furniture. You choose the furniture, install appliances, and handle maintenance inside the house. So in the like whatever you want to add inside your platform, that will be done by you. Now in the PaaS, renting a semi-furnished apartment, the basics are already set up. You can move in and focus on living, not on installing all infrastructure. So you can get a basic level of infrastructure for your needs for your living. And that's how the PaaS operates. Now SaaS, staying in a hotel. Everything is ready to use. Cleaning, maintenance, and services are handled for you. So everything is done by the hotel management. So you don't have to done anything. You just have to deploy your application, and that will be live for all internet. So these are the differences of these three uh, these three services that we have inside our cloud. And this is a very nice example of understanding these three services. So let's go further. Main cloud vendors. Let me amp up the text. There are several cloud vendors offering a variety of services, but AWS, that is Amazon Web Services, is the industry leader with the most extensive offerings and global reach. Other well known cloud providers include Microsoft Azure, a strong competitor, especially in enterprise and hybrid cloud environments. Google Cloud Platform, that is GCP, known for powerful data analysis, AI, and machine learning tools. Alibaba Cloud, a major player in Asia, offering competitive cloud services globally. IBM Cloud focuses on hybrid cloud and AI driven solutions for businesses. Oracle Cloud focuses on enterprise applications and databases. Each of these vendors offers a range of services, but AWS, that is Amazon Web Services, remains the most popular due to its vast infrastructure and support for businesses of all sizes. How companies are using the cloud. For example, Netflix. Netflix runs its entire platform on AWS, so it can scale globally, stay online during peak demands, and stream content reliably to millions of users at once. Spotify uses the cloud to handle millions of songs and users, scaling quickly when new music or feature are released. Instagram relies on the cloud to store massive amount of photos and videos and deliver them fast to users around the world. Online stores uses the cloud to handle traffic spikes during Black Friday without buying permanent infrastructure. These companies use the cloud because it lets them scale, easily reduce costs, stay reliable, and focus on improving their products instead of managing hardware. Next, you will apply these same ideas by deploying your cybersecurity training app in a simulated cloud environment, and that will be very interesting. So, let's answer the questions. What is the characteristic of cloud environments that enables you to handle an unexpected increase in access for your application? So, that will be scalability. The next question is, what is the most common type of cloud deployment used? That is public cloud. And third question is, suppose you want to deploy an application on the internet, focusing only on application deployment and leaving infrastructure to others. What type of cloud service is the best? So what basically you are doing inside this is only deploying your application and leaving the infrastructure to the other people to manage. So that will be done by a PaaS. Okay, so now let's go to our task 3, which is deploying a cloud instance. So far, you have learned what cloud computing is and why companies use it. Now it's time to see those ideas in action by deploying a cloud environment to launch your cybersecurity app training. In this exercise, you will use a cloud interface similar to the AWS environment. The goal is not to memorize buttons, but to understand how cloud resources are easily created and managed in real world scenario. Open the Cloud Console site by clicking on the View Site button below, and let's create your cloud environment. So let me click on the View Site button, and let me read this wall of text so that we can. Okay, so basic cloud terminology. To complete this exercise, you only need to understand the few basic concepts for AWS. EC2, virtual computer and server. So EC2 represents a virtual computer in the cloud. Just like a real computer, it has a CPU and memory and can run applications. Whenever you add an EC2 instance, you are adding a computer to your environment. Okay, here we see the EC2 virtual machine. Total VMs created is 2. Okay. Instance type, for example, T2, T3, comma M5. And I'm not seeing those here. Okay. So these are the three that is instances. Instance types describe how powerful the virtual machine computer is. Some have more CPU and RAM and are therefore more expensive. You choose the instance type based on your needs, knowing that bigger instances is equal to more power plus higher cost, and the minor instances have less power with low cost. Deploying your environment. You will create three virtual computers, that means EC2 instances, to host your cybersecurity training application. This aligns with the infrastructure as a service, that is IaaS model you previously learned. As cybersecurity practices often require full access to the operating systems, This allows you to install tools, configure the system, and safely simulate attacks and defenses, just like in the real world environments. Picking your region. So from this drop down menu, we can pick our region. First, you need to choose a region where your resources will live. You can do it in the top right of your screen, like this. A region represents a geographical location, for example, Europe and North America. Creating lab machines. Now go to the Create Lab Machine block on the right side of the page to create the lab machines for your application. And where is that? Why I'm not seeing? Oh, let me see the screenshot. So create virtual machine. So create virtual machine. From this box, we are able to create our virtual machine. First, let's create your application interface machine. Set the following configurations. So instance name is application interface. Let me copy that and paste it here. The instance type is T3 micro. T3 micro. It is already selected. Now the run state is running. And then I think I have to click on the create VM button. But let's see how they want us to go. Now let's create two testing computers for users to practice their cybersecurity skills. Since these are test machines, let's use a most powerful instance type, which is M5 large. I think I have to click on this button. I've already clicked on that. So this is the application interface that we have created just now. Now what I have to do is to create the instance. I think I have to do these things also in that part. So create, and this will the M5. It's running straight. Now create this machine, and we can see it here. Why it's showing only one machine? Where is my previous machine? No problem. We can add that again. So this one and this will go two, and this will be M5, and it's running state. Let me create, and the first one, which is application interface. So copy and paste T3 micro running create. Now these are the three machines that we have created just now. And yes, that's what we are seeing right here. And after that, billing analysis. Let's analyze how much credit is costing our environment by navigating to the billing section at the bottom of the page. So this is the bottom of the page, and it is costing us 70, 18, and 10. And the total is 170. Am I supposed to drop those? But we don't have an option, and this is 170 credits per month. Currently, you are still developing your application, so users have not yet accessed your platform. We can optimize costs by stopping the two study machines and reviewing the new cost of your environment. So how the cloud like AWS, Amazon Web Services works is that if you have like the example says here that we have three machines but we don't have users to access those machines. So what we have to do is we only have to pay for the resources that we are consumed or we are using. So that's the good part for the web services. So the things that we are not using, we can stop those by using this stop button you can see on the screen. So currently you are still developing your application. We have read that. Go to the instances block and click the stop button for both machine 1 and study machine 2. So we can stop these two machines because we don't have users right now. Go to the billing section and you should see that your cost was reduced considerably. So if you go back again, you can see only 30 credits per month. So that's the beauty of cloud computing. This exercise is a clear example of how easily you can change and manage your costs in a cloud environment. Answering the following questions to conclude your learning about cloud computing. So let's answer the questions. What is the total cost of credits of the entire environment if study machine 1 and study machine 2 was stopped? That is 30. How many credits does an M5 large EC2 instance cost per month? So we can check that here. So M5 dot large costs us 70 credits. So let me write 70 here. What is the total cost of credits if only the new instances were created are running? So what we have created is these three instances, and if these three are running, as you can see now, I'm seeing the stop button. Previously we were seeing the start button, and that will cost us 170 per month. So we can write here is 170. And why? What is the total cost of credits if only the new instances were created are running? Okay, so we have to stop the other instances that are previously running. And these are the two instances that are previously running. So now our cost becomes 150. So I have to read the questions carefully. What would be the total cost of the entire environment you created if you added a third T3A small study machine? So let's add one more machine. Let's name that 3, and this will be T3 small. And why it's say A? I don't know. We don't have option with A. So let me create that machine, and you can see that that machine 3 appeared here. Now let me start the whole environment, and let's see what the cost becomes. So it will 188, and that's the right answer. So this is the room that we have completed, and we learned about the cloud services and how we can manage our cloud. If you are managing your own cloud and you have machines, you can manage those machines by simply adding and removing the machines like we have done in this task. So let's go to our task 4. In this room, we explored the core ideas behind cloud computing and how it enables flexible, scalable, and cost effective access to computing resources. Key terminology. Let's quickly review some concepts we learned in this room. Public cloud. Cloud services you access over the internet that many people and companies share. And what is the public cloud? A cloud built just for one company so they have more control and security. Hybrid cloud, a mix of public and private clouds that can work together and share data. IaaS, a service where you rent basic computer parts like servers and storage for the cloud. PaaS, a service that gives you a ready to use environment to build and run apps without managing servers. SaaS platform, SaaS service, not platform, service. Software you use only without installing anything like Gmail or Zoom. EC2, Amazon's cloud computer that you can easily create, use, and resize whenever you need them. We also concluded that the key benefits of cloud computing are scalability, on demand self service, pay only for what you use, security, high availability, global access. further learning. You are now ready to explore the next key area, operating systems. In the operating system introduction room, you will learn how OS components manage hardware processes, memory, and security. This knowledge is essential for understanding how cloud systems run applications behind the scenes. And as you can see, we have done our room, cloud computing basics. You can share your achievement. Let's go to the dashboard. What we are going to do in our next video is operating system basics, and this will be a very important room, because in this room you will come to understand that what Windows basics, and more importantly that the Linux CLI basics and Windows CLI basics, because you are you majority of the time you are going to use the command line basics or command line tools in the TryHackMe series. Like in my previous video where I have done the gallery room, all the things that I have done on that room is it run around the terminal, and that is what a CLI is, command line interface. So majority of the time, if you are dealing with the Linux machines, you have to run your commands inside a Linux CLI, that is command line interface. But if you are dealing with the stuff like Active Directory, you have to know about the Windows CLI basics like type and dir. Suppose that you have a file that is user.txt, but if that user.txt is inside a Windows machine and you want to access that user.txt using a Windows machine, so inside a Windows machine you have a command prompt, that is cmd prompt, and in that prompt your Linux commands won't work. So you have to learn the Windows CLI basics. So if you want to cat out the, not cat out, cat will be used inside Linux. If you want to see the content of the user text, you have to type the type and the user dot text, and that will show you the content inside that user text. But if you are using a Linux machine and you have that same user.txt file, what you have to do is to take out the text from the user.txt file. What you have to use is cat. So cat command will use to take out that text from that user text. So the conclusion is why I'm saying all these things, because the Linux CLI basics and the Windows CLI basics is very important for us to understand. So uh, I think I'm talking a lot, and I hope you like this video. If you do like this video, please like and subscribe this channel. It will help me to grow this channel, and I will meet you in our next room, which is operating system basics. So bye bye and stay safe.